Hi, this is Mikhail. This is an overview and the demo of the leader election merge requests. But first, some background. So the functionality in the agent is split into modules so that the program is not a big monolith, but has some internal structure. Modules are, well, each module quite often is split into server and agent side component. So there are basically server modules and agent modules. Both server and agent modules have individual APIs that they can call. This is the server API, which is the same as the common API. Then there in this thing as well. And then there is configuration that in this case, the server module is given some configuration and the agent module is given some configuration as well. So the problem is that sometimes, depending on configuration, modules may need to only run as a singleton. So we have active and passive, that's how I call them here, modules. Some of them are active, like GitOps, container security scanning, and then more here, like Helm support in the future. We only want at most one instance of agent kpod to be acting on the configuration for efficiency and other reasons. And there are some other modules that are always on, basically. So for these modules, for active modules, you want to do leader election, basically, so that only one is active at the same time. But we only want to run leader election if the module is active, so is configured to perform some functionality. And if configuration changes, which the user can do dynamically using a configuration file, then the module should say, I don't want to participate in leader election if I'm not interested. Or on the opposite, if this is enabled, then the module may signal that it needs to be executed if configuration is enabled. So this is quite a tricky problem because there are multiple kind of moving parts, dynamic configuration, and plus multiple modules with such dynamic configuration, where each may say I'm enabled, I'm disabled, and if at least one is enabled, then we need to run leader election. If none are enabled, then we don't need to run leader election. Plus, I really wanted to optimize for simplicity so that when I'm building a module, I get a simple API, a way for a module to say, I'm interested in this functionality, or I'm not interested, then, the module should just be what it is today without any implications. And it looks like this. This is how it looks today. A module needs to implement these three functions, this interface, and it's fed with configuration and like dynamically. So when the user changes configuration, the module gets a value from the channel, gets that configuration basically. So this is the interface I came up with. It's a leader module. So one extra method, this has the same signature. I just wanted to add extra docs here. That's why I added it here as well. And from that perspective, I think this looks really clean. So we have this GitOps agent module, and this is the diff basically. If this function returns true, that means this module should be ran for a particular configuration. So, you know, as you see, if there are manifest projects in configuration, then this module should be ran if this agent K instance pod wins the leader election. And same with the starboard vulnerability. If it's configured, if the module is configured, then it wants to participate in the election. Okay, but yeah, this looks really clean, but the implementation is quite tricky, and that's what I wanted to show. So first, we wrap modules here. And we can this file. No, this file. So if this module implements leader module, then we want to wrap it in a special wrapper that will check if what is it? Wrapper is here, of course. Yes. So if the module wants to run for this configuration, then yeah, we push it to this runner, and then the runner runs the election somewhere here. Yeah, this is F4 with select, quite an interesting pattern. Basically, this is a runner. This is an actor pattern from what was the language called? I forgot. Anyway, so that basically this one uses the same pattern for with the select. So it's like I think of this pattern as like imagine a separate process, a separate program that runs and processes incoming and outgoing signals basically, and it holds some state. So in this case, we have some state as fields, as variables and fields. And we get incoming configuration, we do things, and then we send configuration to another actor, basically. And then we get signals from that other actor here as well. And this is that other actor. So also think of this as a different like program that acts on signals, time to stop, time to add a function that wants to run as a leader, and time to stop, and we started leading, and we stopped leading. Like it's a thing that dynamically processes incoming signals and dispatches signals to other actors. And here we have automatas based on status of that actor, basically. So actors plus finite automata, basically. These are two ideas that I used here. Yeah, based on current state and incoming signals, we make decisions about what we do next. Yeah, anyway. you can dig into this code, and I tried to leave a lot of comments, yeah, on your own, and hopefully that is not like it was difficult, but I think the clean API is worth it. Anyway, I wanted to demo this. So I have two configurations, Rancher running locally, and this runs against staging. You can see that is staging. And this is the first one. Let's run the second one. I have it here. Golang likes to compile things every time for no reason. Okay, we have two running. One important thing is they use different pod names. So as if they are, this one is the second one and this one was the first one. So as if they are different pods, because pod name is used for identity. So each one is a separate thing. And they understand who is the leader now because they have different names, and they are trying to grab the lock using that particular name. So okay, we have both running, and then let's change the configuration. Oh, actually, let's check. Let's check if they're running. Yes, this is the super agent. Let's edit the staging. Okay. This will also kick off a CI job, but that shouldn't interfere. But we may see some logs from the CI tunnel. So I have enabled GitOps. It was disabled before, as you saw. And now, okay, attempt to acquire leader list. That's a new message. And this one attempted and succeeded. And this was 1644.41, and this is 1644.43. So this one won by 2 seconds, basically. And then it ran GitOps, applied the resources, and this one did not. Okay, let's stop this one. And now this one acquired the lock and also synchronized. Oh, now this is the logs from CI tunnel, from the CI job that lists pods, nothing else. Okay. Yeah, acquired leads. Now let's run the second one again. It should try to grab the lock and fail. Well, it doesn't fail. It keep trying. It keeps trying. We just don't see anything. We can also do rents and see that the second one became leader, and then the first one became the leader when we stopped the second one. There's no event for when it stopped being a leader, and I send a pull request to Kubernetes libraries to publish such an event. So hopefully we'll get that. Okay, let's disable GitOps. We see how they react. Muted. I think we are polling the server every like 10 seconds. So synchronizing objects and then line. So we canceled. Yeah. So there is a race between module receiving the stop signal and the configuration that it gets. So it gets configuration first in this case. Okay. And now we can also look at this is the lease object in the default namespace, and we see that no one is the leader here. And we enable it. Someone will become the leader. Yep. Yeah. So this one must be the leader. Yep. This one is two. Yep. Agent fork lock. So it seemed to work. And that's the demo. Thank you.